So in this section, we will talk about properties of alkanes, otherwise known as hydrocarbons. So here are some images of hydrocarbons or alkanes that you may know. It ranges from things like propane, which is used in your barbecues, or the wax that's on your apple, or the oil that you see in the news that is a concern in oil spills and environmental concern. So we'll talk about the properties of all these alkanes, and the key difference in all these alkanes is the length of their chain. How many carbons is composed in that alkane. So it turns out from the smallest alkane of 1 carbon up to 18, 19 carbons of alkanes, you will have different properties. And these properties, again, you have to think back about London dispersion forces. Remember that alkanes are only carbon and hydrogen, so they are not polar. Because they are not polar, they don't have dipole-dipole, they don't have hydrogen bonding forces, which are very strong forces. So they only have London dispersion. And it turns out the larger your molecule is, the larger your London dispersion force is also. And what happens when you have a large intermolecular force like a London dispersion force? You will have higher boiling points. What does it mean to have a higher boiling point? That means at room temperature, you will have a more stable molecule. So let's go back. If you have low intermolecular force with one another, your molecules don't interact much with one another, you tend to become a gas, right? And if you have a little bit more interaction, a little bit more intermolecular force, you might become a liquid. And if you have a lot of interaction that you stick to each other a lot, you are basically a solid, right? So that's why you want to think about when we talk about intermolecular force and properties of alkanes. So we'll start from the bottom. From the bottom of this list, we have alkanes that range from 1 to 4 carbons in length, right? So what are some examples? The first one, if we have only 1 carbon, we call that a methane. And again, where is methane found? Right? Methane you may use in your everyday cooking when you turn on your stove, right? So that's a gas, correct? Where's another one that you may know? Propane. Propane or butane is some of the gases that are kept in a tank because they are gases also. And these gases can be burned to give you a fire for your barbecue, for example. Okay, so from 1 to 4, they're very low in intermolecular force because they have low London dispersion force because they're small in molar mass. Therefore, they are gases. Now, when you go up to 5 and beyond, 5 to 8, you start to have a little bit more mass, so therefore a little bit more London dispersion force. Therefore, sticking together more, you start to become liquid. The most prominent one of these is octane. Where have you heard of octane? Octane rating when you go pump the gas, right? So when you pump your gas at the gas station, you are getting some octane in there. And octane basically is a carbon of 8. It's a chain of carbon with 8 carbons in it. So gasoline is what phase? It's liquid phase, right? So that's our example. Now you can get even more liquids when you have alkanes with 9 to 17 carbons in length. But they may become a little bit more dense in liquid and a little stickier in liquid, like motor oil or mineral oil or kerosene, right? So these are still liquid, but they're very kind of sticky and dense, okay? And most of them are used in burning to get some kind of heat or energy from. Okay, now once you go beyond 17 to 18 length in carbon, you start to transition from liquid into solid. Our prime example is wax. Wax is basically alkane, a chain of carbon that is 18 carbon long or more. Right, so the wax on your apple or the candle that you burn at home, those are also alkanes. Again, because they have high molar masses, because they're long, they have more London dispersion force, therefore more intermolecular force, therefore more attraction, becoming solid at room temperature. Okay, so now let's talk about the solubility and the density of alkanes, some other properties of alkanes. What do you know about the solubility of alkanes in water and the density with respect to water? Take a look at this image here of this oil spill, this poor bird stuck with the oil, which is actually not very healthy for this bird, and if it doesn't get cleaned, this bird will, die. But taking a look at this as an example, what can you tell me about the solubility and density of alkanes? Do they mix with the water? No, they're not mixing with the water, therefore it must be insoluble in water. And so what do we know about water? Water is polar, so alkanes must be nonpolar, right? And you also know this because alkanes are just carbon and hydrogen, which are nonpolar bonds, so therefore nonpolar molecules in general. All right, so what about density? What can you tell me about density? This thing is floating on the top of the water, therefore, what does it tell you? It's less dense than water, right? Less things, things that are less dense will rise to the top. So let's recap. Alkanes are nonpolar, they are insoluble in water, and they are less dense than water. All right, so also they are also another property of alkanes that doesn't fit into this, I forgot, is that they are flammable in air. They're very flammable. We've learned about one such type of reaction called the combustion reaction, right? So let's talk about that. The reason why alkanes are always used in as a source of energy, like when you burn gasoline, when you burn kerosene, even when you burn methane, they all are a source of energy, and the reason for that is because these alkanes, these hydrocarbons, have very strong carbon-carbon and carbon-hydrogen bonds. These bonds are strong. So when they have strong bonds and when you break them apart, they release a lot of energy. They will react with oxygen and release carbon dioxide and water in water vapor, and what we also know as combustion reactions. We learned these before. All right. Again, so when they release the energy that is found in the carbon-carbon bond, which again was potential energy, and when they release that, they release it in terms of energy or heat. And when we say something that is heat is released as a product, what do we say? That must be what kind of reaction? Exothermic or endothermic? That is an exothermic reaction, right? Okay, so we talk about all these alkanes. So where do we get them from? It turns out we get them from crude oil. So billions and millions of years ago, there were plants and animals that lived and they die. Their carcass over time decompose and kind of melt down, and with pressure of the earth, become this hydrocarbon, gooey black stuff. And then we now dig them up, and they are a mixture of things actually. And so we can't just use them, right? Because as we just said before, these things have, depending on their length, will have different properties. So we need to separate them out. We need to refine them. So because of that, we have oil refineries. And in oil refineries, we can separate these things out by by heating them up. Based on the temperatures, the different alkanes will be purified out. So for example, you don't even have to heat anything up to get things that are already in the gas phase. So like, for example, natural gas, methane, and stuff like that. We don't have to heat them up. We can just get them as gases. Whereas things that are a little bit more liquid, we have to heat them up like 30 to 200 degrees Celsius to get something like gasoline. Remember that, octane? Things that have higher number of carbons require more heat. So for kerosene and jet fuel, you get 200 to 250 degrees Celsius, and so on and so forth, all the way to things that are very, very long in carbon chains. You might have to eat up to 450, as in that lubricating oil. Okay, so these are some properties of alkanes, things we use in our everyday life, very important to us, gives us a lot of energy and what keeps the economy going. So it's good to know their varieties and where we get them, and some of their properties.